In question 1, we've got the Venn diagram here with A, B, C and their associated probabilities, and we need to determine the probability of B. Well, the probability of B is all of these, so it could be P plus Q plus 0.3, or I could simply say it's 1 minus everything outside of B, so the 0.04, the 0.06 and the 0.4, and therefore we simply state that the probability of B is 1 minus 0.04 plus 0.06 plus 0.4, which gives an answer of 0.5. In part B, we are asked to determine whether or not A and B are independent, and we know that two events are independent if the probability of their intersection is simply the product of their individual probabilities. Well, the probability of A is all of these, which is simply 1 minus the 0.3 and the 0.4. So we've got probability of A is 1 minus 0.3 plus 0.4, which gives an answer of 0.3. We can also see that the probability of A intersection B, so the common is the P plus Q. So we've got probability of A intersection B is equal to P plus Q, which can also be written as 1 minus everything but P plus Q, so the 0.04, the 0.06, the 0.3 and the 0.4. So this can be written as this, 1 minus 0.04 plus 0.06 plus 0.3 plus 0.4, which gives an answer of 0.2, and therefore we have that the probability of A times the probability of B is simply 0.3 times 0.5, which is 0.15, which we can see that does not agree with the 0.2, which is the probability of A intersection B. So we say not equal to 0.2, which is the probability of A intersection B, and therefore we conclude that the two events A and B are not independent. Remember, you need to explicitly compare the product of the probabilities with the probability of the intersection to justify the conclusion. We are then told that the probability of C given B is equal to the probability of C, and we need to find the value of P and the value of Q. So the probability of C given B means I'm surely in B, so let me shade B, and the probability that I'm in C is what I've shaded here, the intersection essentially between C and B, and we are told that this is equal to the probability of C. So we've got that the probability of C given B will be the intersection, the P over the P plus Q plus 0.3, which is the probability of B. Now, this is known to be equal to the probability of C, and we can see that the probability of C is the 0.06 plus P. So we've got 0.06 plus P on the right-hand side. Now, we also know that P plus Q should be such that the sum of the probabilities is 1. So we've got that 0.04 plus 0.06 plus P plus Q plus 0.3 plus 0.4 is equal to 1. And therefore, we get that P plus Q plus 0.8 is 1. So P plus Q is 0.2. This means I can go back to this expression here and replace the P plus Q with the 0.2 in order to arrive at an equation that involves P only. So we've got that P over the 0.2 plus 0.3 is equal to 0.06 plus P. So P over 0.5 is 0.06 plus P, which leads to 2P is 0.06 plus P, and therefore P is 0.06. Now to find Q, the only thing that remains is to substitute the value of P being 0.06 there. So we've got 0.06 plus Q is 0.2, and therefore Q is 0.14. In part D, we are told that there's an event D such that A and D are mutually exclusive, and also the probability of B intersection D is greater than 0, and we need to draw a possible position for the event D. Now, if A and D are mutually exclusive, this means they have nothing in common, so they would appear as disjoint circles, the A and the D, and the probability of B intersection D being greater than 0 means there is at least some part that's overlapping between B and D. So one possible position for D would be here, so some overlapping area between B and D, or it could even be drawn entirely within B as shown here, in which case D is a subset of B. In any case, we cannot have any intersection with A because A and D are mutually exclusive. In question 2, we've got a large company analyzing how much money it's spending on paper in its offices. So we've got some data on 12 randomly selected offices, and this is the summary statistics provided here. We need to show that SXP is 231.25, and we know that SXP is sigma XP minus sigma X times sigma P over N. So sigma XP is given to be 2,347 minus 93 times 273 over N, which is 12, and this gives an answer of 231.25 as required. In part B, we need to find the product moment correlation coefficient for this data, and let me start by reminding you that the R, the product moment correlation coefficient, is given by SXP over the square root of SXX times the SPP. So let me start by calculating SPP, which is simply sigma P squared minus sigma P all squared over N. In our case, this is 6,602.72 minus 273 squared over 12, which gives an answer of 391.97, and therefore the product moment correlation coefficient will be the 231.25, which we found in part A, over the square root of 148.25 times the 391.97, the SXX times the SPP, which gives an answer of 0.959, correct to 3 significant figures. In part C, we need to find the equation of the regression line of P on X in the form P is A plus BX, and I will start by finding B, the gradient. We know that this is given by SXP over SXX, which is 231.25 over 148.25, which gives an answer of 925 over 593, which correct to 3 significant figures is 1.56. Now, to proceed in finding A, the intercept of the regression line, we know that A is P bar minus BX bar, which is 273 over 12, the mean of P, minus the exact value we found for B, 925 over 593, times the mean of X, which is 93 over 12, and this gives an answer of 6,322 over 593, which correct to 3 significant figures is 10.7, and therefore we conclude that P is 10.7 plus 1.56x. Please be careful that when you state the equation of the regression line, the gradient and the y-intercept are given correct to 3SF and not in exact form, because these are essentially estimates because they are based on the collected data. In part D, we are asked to give an interpretation of the gradient of the regression line, the 1.56, and we know that this represents the change in y for every extra unit in X. So in our case, we need to put this in context. So for every extra employee, the amount spent on paper per year increases by $156. Remember that X was measuring the amount of dollars in hundreds of dollars. That's why the 1.56 became $156. And your answer will be correct only if you mention employee and paper, so if you put it in context. The director of the company wishes to reduce the amount spent on paper each year, and therefore they produce this new model, and we need to use the data for the 93 employees from the 12 offices to estimate the percentage saving under this new model. Now to do this, I will start by calculating the actual amount spent per office. So it's the actual mean amount spent, which is the total amount spent, the sigma p, divided by 12, which is the 12 offices, times 100, because this was measured in hundreds of dollars. So this is 100 times 273 over 12, which gives an answer of $2,275. This is the mean amount spent per office, the actual figure. And under this new model, I will start by determining the equation of the regression line as proposed by the director. So this is P equal to 4 over 5 times 10.7 plus a half times 1.56x. So we get P is 8.56 plus 0.78x. So to find the predicted mean amount spent, let me start by stating that P bar is 8.56 plus 0.78x bar. So in our case, we know that the average number of employees per office is 93 over 12. So P bar is 8.56 plus 0.78 times 93 over 12. So we're trying to find the mean amount spent per office under the director's model. This gives P bar to be 14.605, which means we're looking at $1,460.5, and therefore I can proceed in calculating the percentage savings. So we've got an original cost of $2,275 dropping to 1460.5. So the percentage saving is 2275 minus 1,460.5 divided by the 2275, which was the original, times 100%, which gives an answer of 35.8%. The examiner here is accepting anything which rounds to 36%. In question 3, we've got a stem and leaf diagram showing the ages of 35 male passengers, and we need to find the median age of the male passengers. Well, we will start by doing 35, the total number of observations divided by 2. This gives an answer of 17.5, and therefore we conclude that the median should be given by the 18th value, the 18th observation. Remember that when we do n over 2, if we get an integer, we take that and the next one, their midpoint. If it's not an integer, we round up and we find the corresponding observation. Now in this case, the 18th observation, it's 1 plus 2, 3 plus 4, 7, and 7, 14, 15, 16, 17, 18. So 53 is the median in this case. In part B, we need to show that the interquartile range of these ages is 16, so I need to find the upper and the lower quartiles. Now for the lower quartile Q1, I'll be doing a quarter of the observations, a quarter times 35, which is 8.75, and therefore we know that this will be the 9th value. So again, going on my stem and leaf diagram, the 9th observation is a 45. And for Q3, I'll be doing 3 over 4 times 35. This gives an answer of 26.25. Again, I will round up. I go to the 27th value. And if I go through my stem and leaf diagram, I find that this is 61. The interquartile range is simply the difference between the upper and the lower quartile. So it's going to be 61 minus 45, which gives me 16. As required. We are then provided with a rule of determining outliers, and we need to show that this means we've got 3 outliers in our data. So the lower limit is given by Q1 minus 1.5 times the interquartile range, which is 45 minus 1.5 times 16, which gives an answer of 21. Whereas the upper limit is Q3 plus 1.5 times the interquartile range, which is 61 plus 1.5 times 16, which is 85. So anything below 21 and anything above 85 will be classified as an outlier. Going quickly to my stem and leaf diagram, I can see that the 13, the 87, and the 88 are all beyond the limits, and therefore I can simply say that 13 is less than 21, and 87 is greater than 85, and 88 is greater than 85, which means we've got 3 outliers as required. We are then asked to draw a box plot for the ages of the male passengers, and I will start by drawing the box, which consists of the quartiles. So there it is, Q1, the median, and Q3. Now my whiskers will go up to the greatest observation that is not deemed to be an outlier. So we go to 76 and up to 27. These are the last observed values that are not outliers, and we indicate the outliers with crosses. We've got a total of 3 outliers. Alternatively, we could have extended the whiskers up to the theoretical limit for outliers. So what we have calculated before as 21 and 85, because we've got outliers on either side of the box. In part E, we need to comment on any difference in the distribution of ages between males and females, stating the values of any statistics that we might use. So looking at the box plot, we can see that the box for the males is to the left of the box of the females. This simply means that males are on average younger than females, and I could use the median to compare this. I can see that for males the median age is 53, whereas for females this is 67. So I could simply write that females are on average older than males, or males are on average younger than females, because the median age is 67 versus the 53. Another comparison I could make would be on the spread of the data. I could look at the ranges. So for males, we go from 17 up to 88, whereas for the females, we go from 20 up to 93. And therefore, we could say that the ages of the males are more spread out than the females, because the range is 75 versus 73 for females. In part F, we are told that Anja, along with her 2 daughters and a granddaughter, joined the cruise. Now, the granddaughter is younger than both of the daughters, and Anja had her 23rd birthday on the day her eldest daughter was born. Now, when we include all 4 ages, the box plot does not change, and we need to stay giving reasons. What can we say about the granddaughter's age and Anja's age? Well, we know that the box plot can be split into 4 parts according to Q1, Q2, and Q3. And if the box plot remains unchanged, it means that all 4 of these ages, all 4 new observations were not deemed to be outliers. So it must be the case that we've got 1 in each of the highlighted sections. So based on the fact that the granddaughter is the youngest of the 4, we can conclude that the granddaughter is between 34 and 56 years of age. The 34 is the limit here, and the 56 is the lower quartile. Now, the eldest daughter must be between Q2 and Q3, so the eldest daughter is between 67 and 72. And taking into account the fact that Anja is 23 years older than her eldest daughter, this means that Anja must be between 90 and 95. However, Anja is certainly within the red region here. She's between the 72 and the 93, so she cannot be 95. So since she cannot be more than 93, then we can easily conclude that she's between 90 and 93. In question 4, we've got Mike, who is drawing a ball out of bag A, recording the color, placing it in C, then drawing a second ball from B, recording the color again and placing it in C, and then finally taking a ball at random from bag C. And we need to complete the tree diagram given here. Well, I will start by adding the missing branches, so the red, yellow possibilities for bag C, and I will start by filling in the probabilities. So we know that originally the bag A had 4 red and 2 yellow balls, so the 2/3 shown here is simply the 4/6. I prefer to not simplify my fractions so that the denominator corresponds to the total number of balls in the bag. So if I have 4/6 of picking a red ball, that means I've got 2/6 of picking a yellow ball. Now we've got 4 red balls in bag B, so one of them is yellow. And it's exactly the same probabilities over here in the branch when the first ball drawn from bag A is yellow, so 4 over 5 and 1 over 5. Remember that anything drawn out of A and B is placed into C, which originally had 6 red balls. So I've placed 2 more red balls. That means I've got 8 out of 8 of being red and 0 out of 8 of being yellow. But if I've put red and yellow, that means I've got 7 red and 1 yellow. If I've put a yellow and a red, it's exactly the same thing. So it's gonna be 7 over 8 and 1 over 8. Whereas the yellow scenario means we've got 6 over 8 for a red and 2 over 8 for a yellow. In part B, we need to show that the probability that Mike records a yellow ball exactly twice is 1 over 10. So to get 2 yellow balls, it means that we've got the red, yellow scenario, the yellow, red, yellow scenario, and the yellow, red scenario. So let's look at this. Probability of 2 yellow balls is simply gonna be the probability of red, then yellow, or the probability of yellow, then red, then yellow, and the probability of yellow, then red. And I'm multiplying the probabilities of the branches through which I travel. So it's going to be 4 over 6 times 1 over 5 times 1 over 8 plus the 2 over 6 times 4 over 5 times 1 over 8 plus the 2 over 6 times 1 over 5 times 6 over 8. Plug everything on the calculator to get an answer of 1 over 10 as required. We are then told that Mike records exactly 2 yellow balls, and in light of this information we need to find the probability that the ball drawn from bag A is red. So we are looking at conditional probability here. We're looking at the probability we got a red from A given we had 2 yellow balls. So if I briefly go back to my tree diagram, I know for sure that we had 2 yellow balls, exactly what we have highlighted here, and we are asking what is the probability that we drew the red from A. So it's this one here. So in our case it's gonna be the probability of red, yellow over the probability of 2 yellow balls, which means that the numerator is 4 over 6 times 1 over 5 times 1 over 8, and the denominator is simply the answer we got for part B, the 1 over 10, which gives an answer of 1 over 6. Mike is playing this game a large number of times, each time starting with the bags containing the balls as described above, and the random variable x represents the number of yellow balls recorded in a single game, and we need to find the probability distribution of x. So here is my tree diagram. So if I drew red, that means that the x, the random variable corresponding to the number of yellow balls, is 0. Here it's 1. Here it's 1, then it's 2, then it's 1, then it's 2, and then again 2, and finally 3. It's the yellow scenario. I'll be calculating the probabilities for each of these values of x. So the probability of x being 0 is going to be 4 over 6 times 4 over 5 times 8 over 8, which gives an answer of 8 over 15. The probability of x being equal to 1 is going to be 4 over 6 times 4 over 5 times 0 over 8 plus the 4 over 6 times 1 over 5 times 7 over 8 plus the 2 over 6 times 4 over 5 times 7 over 8, which gives an answer of 7 over 20. We have already found that the probability of x is 2 is simply a tenth, and the probability of x is 3 is going to be 2 over 6 times 1 over 5 times 2 over 8, which gives an answer of 1 over 60, which means I can go on to draw the probability distribution table for the random variable x. X can attain the values of 0, 1, 2, and 3, and the associated probabilities are the ones we just found. It's 8 over 15 for 0, it's 7 over 20 for 1, 1 over 10 for 2, and 1 over 60 for 3. You can easily check that these add up to 1 to confirm that you've got a valid probability distribution. And finally, in part E, we need to find the expectation of x. So this is the table we just obtained. The expectation of x is simply found by multiplying each value of x with its associated probability and adding them up. So it's going to be 0 times 8 over 15, plus 1 times 7 over 20, plus 2 times 1 over 10, plus 3 times 1 over 60, and this gives an answer of 3 over 5. In question 5, we've got the discrete random variable y with the following probability distribution. Q, R, and U are probabilities, and we need to write down the value of the expectation of y. There is no need to calculate here. We just observe that there is symmetry, the -9 with the 9, the -5 with the 5, and the corresponding probabilities being the same, and therefore we can simply conclude that by symmetry the expectation of y should be the midpoint, so it should be 0. In part B, we have that the cumulative distribution function capital F of y satisfies that capital F of 0 is 19 over 30, and we need to show that the value of u turns out to be 4 over 15. Well, I will start by saying that the sum of these should be 1. So we've got that q plus r plus u plus r plus q is equal to 1, leading to 2q plus 2r plus u is equal to 1. Now capital F of 0, the cumulative distribution function, is simply the probability of y less than or equal to 0. So if I'm less than or equal to 0, then it could be -9, -5, or 0. So this is q plus r plus u. So q plus r plus u is given to be 19 over 30. So what I could do is multiply everything by 2 to get 2q plus 2r plus 2u is equal to 19 over 15. We also have that 2q plus 2r plus u is equal to 1. So I can deduct 1 from the other to get that u is equal to 4 over 15 as required. We are then told that the variance of y is 37, and based on this we need to find the value of q and the value of r. Now to find the variance of y, I will start by finding the expectation of y squared, which is -9 squared times q plus -5 squared times r plus 0 squared times u plus 5 squared times r plus 9 squared times q, which gives me 81q plus 25r plus 25r plus 81q, which is 162q plus 50r. Well, the variance of y is simply the expectation of y squared minus the square of the expectation. So this is 37 being equal to 162q plus 50r minus the 0 squared. So it's simply 37 being equal to 162q plus 50r. We also have that 2q plus 2r plus u is equal to 1, the total probability, and therefore since u was found to be 4 over 15, we've got 2q plus 2r plus 4 over 15 is equal to 1, leading to 2q plus 2r is equal to 11 over 15. I will multiply everything by 25, leading to 50q plus 50r is equal to 55 over 3, and therefore I can write this below the established equation here. So I've got 55 over 3 being equal to 50q plus 50r. We are solving simultaneous equations here. I will deduct one from the other, leading to 56 over 3 being equal to 112q, and if I divide both sides by 112, I get that q is a 6th, and I can go back and substitute into this equation here to find the r. So I've got 2 times 1 over 6 plus 2r is equal to 11 over 15. So 1 over 3 plus 2r is 11 over 15, leading to 2r being equal to 2 over 5, and therefore r is 1 over 5. The coordinates of a point P are 12y, and the random variable d represents the length of OP. We need to find the probability distribution of d. So d is simply the distance OP, which is going to be 12 squared plus y squared and all square root. So this is what we're trying to determine. Now, since the coordinates of P depend on y and y is random, then the length is also random. The probability distribution of y is given here, and I will be calculating for each value of y the corresponding value of d, where d is going to be the square root of 12 squared plus y squared. So for negative 9, I get 15. For negative 5, I get 13. For 0, I get 12, then 13, and then 15. So we can easily see that the random variable d can attain the values of 12, 13, and 15. And the corresponding probabilities for 12, it's simply the 4 over 15 when y is 0. For 13, it's when we've got y to be negative 5 or 5. So a fifth plus a fifth is 2 over 5. And finally, for 15, it's when y is negative 9 or 9. So a sixth and a sixth, which gives an answer of a third. If you add these three probabilities up, you of course arrive at the result of 1. In question 6, the height capital H centimeters of books is modeled through a normal distribution with a mean of 25.1 and a standard deviation of 5.5 centimeters, and we need to show that the probability of capital H being greater than 30.8 is 0.15. So we've got H following normal 25.1, 5.5 squared. The probability of capital H being greater than 30.8 is equal to 1 minus the probability of H being less than 30.8. I will proceed by standardizing, and I will deduct the mean and divide by the standard deviation. So minus 25.1 over 5.5. This leads to 1 minus the probability of Z being less than 1.04. So going to my formula booklet for 1.04, the corresponding probability is 0.8508, which means we've got 1 minus 0.8508, which turns out to be 0.1492, which rounds to 0.15 as required. We're then told that the smallest 5% of books and any books taller than 30.8 centimeters will not be placed on the shelves, and all the other books will be placed on the shelves. And we need to find the range of heights of books that will be placed on the shelves. I will start by drawing my bell-shaped curve centered at 25.1. We know that the upper limit is 30.8, so any book greater than 30.8 centimeters in height will not be going on the shelf, and we need to find that value x on the left-hand side such that there's a chance of 5% of a book having a height which is less than x. So essentially we need to solve the probability of h being less than x to be 0.05. So I will proceed by standardizing. So it's the probability of z less than x minus 25.1 over 5.5, which is equal to 0.05. Now I'll be using the small table of values of the normal distribution. So I want the statement here to read probability of z greater than. So in order to do that, I'll be writing probability of z greater than 25.1 minus x over 5.5 is equal to 0.05. And going to the table of values for 0.05, the corresponding z value is 1.6449, which means we have 25.1 minus x over 5.5 is equal to 1.6449. I will cross multiply to get 25.1 minus x is equal to 9.04695, which means that x turns out to be 16.05305. Now remember, we're trying to find the range of heights. So the range of heights can either be given as an interval, or it could simply be the difference between the 30.8 and x. So I'll do 30.8 minus the 16.05305, which gives an answer of 14.7. The examiner is also accepting an interval, so if you write 16.1 up to 30.8, that would also be acceptable. The books that will be placed on the shelves have heights classified as small, medium, or large, and these are split in the ratio 2 to 3 to 3. Now the medium books have heights x, such that x is between M and D, and we need to show that D is 25.8. We surely need a sketch here, a diagram, to help us understand what's going on. So this is where we stand at the moment. We know that all the books that will be placed on the shelf are over here, and the left tail is 0.05 and the right tail is 0.15, which means that all of this is 0.8. We know that there is a value M somewhere here that distinguishes between the small and the medium, and the value D that distinguishes between the medium and the large books. And I'll be splitting these three regions in the ratio 2 to 3 to 3. Well, if all of this is 0.8, and I'll be splitting it into the ratio 2 to 3 to 3, obviously this is going to be 0.2, this is going to be 0.3, and this is going to be 0.3. So to find the value of D, I'll simply say that the probability of H, the height, being less than D is 0.3 plus 0.2 plus 0.05. So let me start by writing this. We've got the probability of H being less than D to be 0.05 plus 0.2 plus 0.3, which is 0.55. I will proceed by standardizing, so it's the probability of Z less than D minus 25.1 over the 5.5, and this is equal to 0.55. So going to the table of values for the normal distribution, I'll be looking to the probabilities, trying to find the value which is closest to 0.55. We can see that this is 0.13, which means that D minus 25.1 over 5.5 is equal to 0.13. If I cross multiply, I get D minus 25.1 is equal to 0.715, which means that D is 25.815, which of course rounds to 25.8, correct to three significant figures as required. Now to find the value of M, I will follow a similar approach. The probability of H being less than M is simply the 0.05 and the 0.2. So this gives an answer of 0.25, which means that we can proceed by standardizing. The probability of Z less than M minus 25.1 over 5.5 is equal to 0.25. Now remember that the table of values for the normal distribution is only giving you probabilities which are greater than 0.5. So to make this greater than 0.5, I will write this as the probability of Z less than 25.1 minus M over 5.5 is equal to 0.75, so 1 minus the probability. And going to the table of values, we'll be looking at 0.75, which is giving me a Z value of 0.67, which means that 25.1 minus M over 5.5 is equal to 0.67. If I cross multiply, I get 25.1 minus M is equal to 3.685, and therefore M turns out to be 21.4. In part D, we want 2 shelves for small books, 3 shelves for medium books, and 3 shelves for large books, and these will be placed one above another and made of wood that is 1 centimeter thick, and we need to work out the minimum total height needed. Well, based on the work we carried out up to now, we know that small books are between 16.1 and 21.4, medium are between 21.4 and 25.8, and large between 25.8 and 30.8. We need to make sure that all the shelves will fit the corresponding books. So for the 2 shelves for the small books, I need to make sure that they are 21.4 centimeters in height to fit any possible small book. So 2 times 21.4 plus 3 times the 25.8, which corresponds to the 3 medium shelves, plus 3 times the 30.8 for the 3 large shelves. and we also need to account for the thickness of the wood. We've got a total of 8 shelves, and each shelf is a centimeter in thickness, so plus 8 times 1, which gives me a total of 220.6 centimeters, and the examiner here is accepting anything which rounds to 221 centimeters.